Hello and welcome! Today, we are diving deep into static electricity. We're going to cover everything you need to know for the AQA 4.2.5 spec so you can walk into your GCSE Physics exam feeling totally confident. So let's kick things off with something I'm pretty sure we've all experienced. You're just walking across a room, maybe shuffling your feet on the carpet. You reach out for a metal doorknob and zap, you get that little surprising shock. So what on earth is actually happening there? Well, that little zap is a perfect real-world example of static electricity. It's all about a buildup of electric charge, and it usually happens when two insulating materials, like say the rubber soles of your shoes and a nylon carpet, get rubbed together. Okay, let's get a proper definition down. A static charge is just an imbalance of electrical charges that kind of hangs out and collects on the surface of an object. And the key word here, the one you've got to remember for your exam, is static. It means the charge is stationary. It's not moving or flowing like the current you'd find in a wire. So, how does this charge even get made in the first place? Well, imagine you rub two insulating materials together. That friction whips up enough energy for these tiny, negatively charged particles, we call them electrons, to literally leap from one surface over to the other. It's a real physical transfer of particles. Now, this is super important, and it's a spot where a lot of people get a bit mixed up. The object that loses those electrons becomes positively charged. But, and this is the key bit, it's not because it gained something positive. It's because it now has more positive protons than it has negative electrons. And of course, the material that snagged all those extra electrons, it becomes negatively charged. And this is where it starts to get really interesting. Once you have these charged objects, they begin to interact with each other in a pretty amazing way. They can actually push or pull on each other from a distance without ever making contact. The fundamental rule is super simple. If the charges are the same, they'll push each other away. They repel. If the charges are opposite, they'll pull towards each other. They attract. This whole interaction is a perfect example of what physicists call a non-contact force. You're already familiar with one, gravity. It pulls you down to Earth without anything physically grabbing you. Well, electrostatic forces work the same way, acting across empty space. This is a really key concept you're going to need for your exam. But hold on a second. If they're not touching, how does one charged object even know another one is nearby? How can it possibly push or pull it from a distance? It kind of sounds like magic, doesn't it? Well, it's not magic, it's physics, and the answer is something called an electric field. You see, every single charged object creates this invisible field of influence all around itself. Think of it as its own personal force field, a region of space where its electrical force can be felt by any other charges that wander in. It's a bit like the Wi-Fi signal from your router. The closer you are to the router, or in our case, the charged object, the stronger the signal, right? Same idea here. The electric field is strongest right next to the object, and that force gets weaker and weaker the further away you get. And this brings us all the way back to that doorknob shock. When the electric field between your charged up finger and that metal doorknob gets strong enough, it can literally rip electrons right through the air itself, creating a tiny, visible lightning bolt, a spark. That's the zap you feel. Okay, so we've got the theory down. Now let's switch gears and put together your ultimate exam toolkit, specifically for the AQA 4.2.5 spec. You can bet you might get asked to draw an electric field patterns, so you have to know these rules. The field lines themselves show the path a positive charge would take. So remember, the arrows always point away from a positive charge, and they always point towards a negative charge. And one more thing. Wherever the lines are bunched up close together, that's where the field is the strongest. And here we go, this is it, your final checklist taken straight from the AQA specification itself. So ask yourself, can you do all of these things? Can you describe how rubbing things together causes static? Can you explain that process using the idea of electron transfer? And can you use the concept of an electric field to explain those non-contact forces? If you can nod your head and say yes to all of these, you are in fantastic shape for this part of the exam. So the next time you get that little zap from a doorknob, you won't just be surprised. You'll actually understand the incredible physics going on behind the scenes. The friction, the transfer of electrons, that buildup of static charge, the creation of an electric field, and finally, that dramatic little spark. You're not just ready for a test question now. You're ready to actually explain the world around you.